this video, we're going to look at how to visually summarize quantitative variables using SAS. So to get started, there's three different files that you want to make sure that you have on your computer. The first one is the Module 6 SAS code. This is located on Canvas, and this is what we're going to be working through in this video. You'll want to make sure that you have the data set that we created in Module 5. So in Module 5, if you followed along with the notes, we created the Kentucky 2020 BRFSS data set. You could also follow along using the data set for your state. And then the third thing, we always want to make sure that we have our code book handy, because again, the code book contains all the valuable information, or not all valuable information, but valuable information about the variables. Alright, so the first thing that we want to do is read in our data set. So to read in our data set, we're going to use the proc import statement. You'll notice next to data file, you need to include the path to where the file is located on your computer, as well as the name of the data set. And so here I'm reading in the Kentucky 2020 BRFSS.csv. Now in the out statement, this is going to be what SAS is going to call the data set. So you're typically going to see work dot. The reason for this is this is where SAS internally stores data sets. And then the name of the data set so that we can call it. And so if we run this, we can see the data set was successfully read in. Alternatively, you could also use the import wizard to read in your data set. If you do that, you don't want to run the proc import statement. And just as a reminder, when you read that in using the import wizard, don't forget that under the member, you need to give the name of the data set. So in this particular case, I'm calling it Kentucky 2020 BRFSS. You can call it whatever you want to if that goes along with your state. Right. So what we're going to do is we are going to explore a quantitative variable, and we're going to see how to create a histogram of that quantitative variable. Now the quantitative variable we're going to be looking at in this video is this one right here. So this variable is located on page 30 of the codebook, and this variable looks at how old you, or ask rather, how old were you when you were first told you had diabetes. So if we look at the values for this variable, notice the variable takes values 1 through 97. Now do be careful here, because 97 actually means 97 and older. The value 98 if the person responded don't know, not sure, and 99 if they refuse to respond. So if we only look at the observations that responded 1 through 96, then this would be considered a quantitative variable. Now we do have to be careful though, because the responses for 97, 98, and 99, those are really categories. But if we remove those observations from the variable, or remove those values rather, we can summarize this and analyze it like a quantitative variable. Now of course, anytime we change a variable, we want to make sure that we talk about that in the report. So here, if this would be a variable that you would want to include, you would want to make sure that below a histogram or any summary you give of this variable, you comment on the fact that ages 97 were removed, don't know, not sure were removed, and refuses were removed from the data set. And when you talk about a variable, you want to be very clear about what was removed. You wouldn't want to just say we removed the values 97, 98, and 99 without giving justification, because someone might think, well, why did you remove those ages? So instead you would say we removed the values that corresponded to 97 and older, don't know, not sure, and refused. So let's see how we can do this. So the first thing I'm going to do is actually use that proc-freq procedure that you saw in Module 5. Now we don't want to use a frequency table to describe a quantitative variable, but it can be useful just to take a kind of a quick glance at the types of values that this variable takes in our data set. So notice here I've got the proc-freq. I'm going to call the Kentucky 2020 data set, and I'm going to call that variable. Alright, looking here at this frequency table, notice we have the different values that the variable takes in the data set, as well as the corresponding frequencies. So for example, there was one person who was told at age 4, there were 10 people who were told at age 30, 27 told at age 60, and so on. The other important piece to look at here is if we look at this third column, remember this is the cumulative frequency. So looking here, we only had 461 actual observations for this variable. we had 2,408 missing. So this kind of highlights why it's so important, when we're reporting our plots or reporting our summaries, that we talk about how many missing observations that we had, because what you're going to find for the BRFSS is, depending on which variable you're looking at, there might be quite a bit of missingness. So going back to our code. So the next thing I'm going to do is, for this variable, I want to remove those categorical responses. So remember that 97 represented 97 or more. And so here, notice 97 doesn't appear, so I don't have to worry about the 97s for this particular data set. But there were 98s and 99s. So we're going to do something very similar to what we did in Module 5 when we removed the refuses for the education variable. So you'll notice this code is very similar. We start out with our data set, and then essentially what we're doing is we're saying, okay, I want you to take the data set and basically copy it to itself, and then define this new variable that we're going to call diabage3 underscore nocat. In other words, we're going to recreate this variable without any of those categorical responses. I'm going to set it equal to the original variable, and then what I'm going to do is, if the original variable is a 98, I want it to be missing in my new variable. If the original had a 99, then I want it to be missing in my new one. So we can run this, check our log, everything looks good, and now we can create our histogram using proc-sgplot. So let's first run this, and then we'll talk about the different pieces of the code. All right, so here is a nice histogram. You can see we have our title here, age when told had diabetes. So notice here when I title the histogram, I'm not using the variable name that's in the code book. I'm actually giving it a descriptive title. The other thing is, note that I've got n equals to 427. That's because there were 427 observations used to create this histogram. So where did the 427 come from? Well, remember that we had 461 total observations, but we removed the 99s and the 98s. So if I take the count of 461 and subtract off those 34 that I removed, you'll end up with 427. On the x-axis we have age, because that's what we were measuring here, and then we have percent or relative frequency along the left-hand side. So looking at our code. So we have proc-sgplot. So the first thing you're going to want to do is call the data set you're working with. The title line is where you put in the title. Y-axis is where you put in the y-axis label, and x-axis is where you put in the x-axis label. And notice that those are in quotations. It doesn't matter if they're single or double. This line right here is where we're actually creating the histogram. So notice after the word histogram, you'll want to give the name of that new variable that has those categories removed. Now, if you're working with a variable that doesn't have any categories in the code book, then you don't have to do that previous step. You can just work with the variable directly. And then these other pieces, these control some of the attributes of the histogram. So this one right here is what creates or makes the histogram red, so you can change the color there. Scale is what makes that a relative frequency or percent instead of a count. And remember, for your reports, you want to be working with relative frequencies. And then the last piece here is bin width and bin start. What bin width and bin start are doing is they're controlling the width of the bars, and they're controlling where the midpoint of the bars start. So if you'll notice here, I've got a little bit of a comment here that I'll let you read, but I'll just kind of give you a synopsis of why we need those two pieces, and then this comes from this website. So I do suggest having a look at this as well as that website. So the choice of bin width and bin start is really going to depend on your variable. In this case, I was working with age, and so I thought, you know, a width of 10 would be really nice for ages. But for example, if I didn't include the bin start, I want to show you what happens. So if I run this, notice I've got that nice width of 10, which makes sense for age, but if I look at this bottom bar, it's centered at 0. And so essentially what is happening is we don't have anybody at age 0, but we did have that one person that was 4 years old. And so they're getting placed in this bin, but it looks like that bin extends past 0, and since we have ages, that doesn't really make sense. So instead of having my bin start at 0, what I really want is my bin start to be at 5 for this width. So going back, if I add that back in, notice now that this bar right here is a width of 10 from 0 to 10, and it's centered at 5. So then the name bin start there is a little deceptive because it sounds like the left-hand side is starting at 5. It's really where the midpoint of the first bar is starting. And so again, the choice of an appropriate width and where to start is going to depend on your data. You know, if you're creating a histogram of a variable that just takes values between 0 and 1, it wouldn't make sense to have a bin width of 10. So that's going to really depend on what variable it is you're summarizing, and you might just have to play around with it for a little bit. Now, of course, if you have trouble with that, just let me know, and I can take a look at it and help you make some choices. And that is going to conclude the video for creating histograms in SAS. So as always, if you have any questions, please let me know.